Hey guys, this is the Vincent Code, and today's video let's talk about stack and queue in data structures. So first of all, what is a stack? So by definition, a stack is an abstract data type commonly used in most programming languages. It is named stack because it behaves like a real-world stack. For example, a deck of cards or a pile of plates. Here are the basic operations of stack. So first we have push, and also we have pop. So push, this operation is used when you store an element on the stack, and pop to remove an element from the stack. And we have also other functions. We have repeat, full, and empty. Here we have the push operation. So this is the representation of the push operations. So for example, this is your stack. So for example, we declare an array. So by the way, in stack we can implement stack by means of array, structure, pointer, and linked list. So this is the representation of the push operation. So when you add an element on your stack, so this is what happens. So this is your stack, an empty stack. So whenever you push an element, so it will add on your stack. So for example, this one, so example, you have an integer. So when you push integer 1 on your stack, so it will add on your stack. And when you push another element, for example 2, so it will go on top of your previous element. So here, as you can see, we have top from -1 to 0 to +1. It's because this variable, this is a variable, this is a global variable, so that with whichever part of your program we can access this variable. So this variable here indicates the number of data elements on your stack. So here we initialized it to -1, and whenever we add an element, we will increment it by 1. So from -1 incremented by 1, so we have here 0, and then increment by 1 again, so 1. So this is the code implementation of stack. So we have void push, and then our parameter, the data element that we will add in our stack. So the first thing that we will do is to check if the stack is full. So we have here called the isFull function, so we will discuss this later. So if the stack is full, so if the stack is not full, so if this function return a false, so we will proceed here. So basically this just means that if your stack is not full, so it means that we have space for another element to be added. So we will execute this code here. So we will increment top by 1. So as you can see here, from -1 to 0 to 1, because top, the value of top, we will use it to get the place for our next for the data that we will be added. So increment it by 1. Top equals top plus 1, or you could say top plus plus, and then here we will get the top. So this is our array, so stack is our array, so stack and then top. So whatever the value of top, so that is the place that we will store our data. So that is if the stack is not full. Else, if the stack is full, so we will just simply print an error message say cannot insert data, stack is full. So that is the procedure on how we will insert an element on our stack. So next is the pop. So pop is to remove an element. So as you can see here, from 3 elements, so we will remove 3 by using pop operation. So as you can see here, top is equal to 2, and after we pop, top becomes 1. So here is the code implementation of the pop. So we have here the pop function. So first thing that we will do is to check if the stack is empty. So in push we will check if the stack is full, and while in pop we will check if the stack is empty. So if stack is not empty, so that means that we have stack, so our stack is not empty. So here we will execute this code here. So data equals stack top, so that means we will get the top element of our data. So this we will do this for example, if you want to display the removed element, so we will store the top element to data. So this stack top here, this is the data that we will be removing, and then after that we will decrement the top. So top equals top minus 1. So as you can see here, instead that 3 is the top, so after we will remove 3, 2 now will be the top element of our stack. So that's why we will decrement the top. So whenever we access the top element, it will return the new top element, and then here we will return the data, so again for display purposes. So else, if the stack is empty, so could not retrieve data, stack is empty. So technically we are not deleting the element here, we just simply disregard this element, so that whenever we want to display the array, for example in this example we are using array, so it will not display the top element because we decrement our top, so that the place of this element will not be accessed by our array. So next, so those are the basic operations in stack. So here we have the other functions. So we have pick. So pick function is to simply check the top element. So we just simply return stack top. So we will just simply get the top element and return it. So pick is a function that is used to display the top element of our stack. And then is full, so this is the code of is full. So we have here a boolean function, so bool is full. So if top is equal to max size, so in array, so whatever the size that you set as your max size, so if the top will be equal to that, that means that our stack is full, so we will return true. So we will return true because this is a boolean function, else return false. So this is the syntax that you will remember. If top is equal to max size, then that is full, else that is not full. So we have space for our data to be pushed. So is full function is used in push operation. So before you will add an data element, so always check if your stack is full or not. And then here is empty, so this operation is this function is used when we pop an element. So you have here boolean function again. If top is still equal to our initialized value of top, then that means that our top our stock, we haven't added an element on our stock yet, because every time we push an element on our stock, we will increment top by 1. So if top is still equal to -1, that means that we haven't incremented top, so we haven't added a data element on our stock. Then if we have here, if top is equal to -1, return true, else return false. So that is the other functions of our stack. Push to store an element on the stack, pop, remove an element from the stack, and then pick, get the top element of the stack without removing it, and then full, check if the stack is full and is empty, check if the stack is empty. So these are the functions and operations involving stack. So stack is very easy to understand. So if you have any questions, just comment it down below in our comment section, and I will try my best to reply on your inquiries. So now let's move on to our queue. So queue is quite similar to stack. So here it is also an abstract data structure. Unlike stacks, a queue is open at both ends. One end is always used to insert data or in queue, and the other is used to remove data or dequeue. So from in stack, we can only access at one end. So the operation involved in stack is what we call LIFO, last in first out. But here in queue, we have here FIFO, the first in, and the data that is first inputted will be first to get out of our queue. So we have here in queue is to add data element on our queue, and dequeue is to remove data element from the queue. So we can only in queue at the back or the rear of our queue, and dequeue at front of our queue. So basic operations: in queue, add an element or an item to the queue, and dequeue is to remove an item or element from the queue. And we have here other functions, so same with stack. So these are three important functions. So pick gets the element of the front of the queue without removing it. So always remember, pick is used to get the front of the queue. Is full, checks if the queue is full, and is empty, checks if the queue is empty. So is full function is used when we in queue an item or an element, and is empty is used when we dequeue an item or an element. So here is the in queue operation. So this is the representation of in queue operation. So the data element will be added at the back end of our queue. So just like when you fall in line in supermarket or an ATM machine, so when you add to the line, so you always add at the back of the line. So here is the code implementation of in queue. So you have here void in queue and the data that we will be added. So if queue is full, that means that we don't have space for another element to be added. So we will return 0, or we will print an error message that says that our queue is full, cannot insert element. Else, if our queue is not full, so here we have rear equals rear plus 1. So rear is similar with back. So as imagine that back is our rear, then q rear equals data. So for example, our front here, so this is the first element that has been added. So for example, this is 0 1 2 3 4. So the last element is 4. So the element that we will be added is we will add this into 5. So that's why we have here rear equals rear plus 1. So when we add an element, so the variable that we will increment is the rear. So when we in Q, we always increment the rear so that we can get the empty space or empty location for our new data that will be added. So and then return the return one, or return, you can say return message that says item has been successfully added. So next, dequeue. So here dequeue is to remove an element. So in line, where can you remove an element? So at the front. So after just like in real life, so for example when you line for an ATM machine, so after you've done using the ATM machine, so you are removed from the line. So that's why when you remove an item from the queue, so always remove this from the front. So here is the representation. So the queue from the front, and then here is the code implementation. So you have here the queue. So again, check if the, just like the stock, so when you remove an element, check if the, so here check if queue is empty. So if queue is empty, that means that there's no element to be removed. So you will return 0 or an error message that says that the queue is empty. Else if you have something to be removed, so we have here int data equals queue front, and then front equals front minus 1. So here we get the queue front. So queue front is this one. This is our front, and after that we will decrement we will increment our front. So for example, this is 0, this is 1 2 3 and 0 1 2 3 4 and 5. So this one here, this is our front. So the initial value of our front is 0. So for it to be removed, we will increment our front. So from 0, we will increment it by 1. So our front now is the Q1. So this is the Q1. So again, technically we are not deleting the element, we are just disregarding this. So after we increment this by 1, so this element here or an item is disregarded by our array. So after that, we will return the data that we have removed, or we will return data, and also we can display a message that says successfully dequeued, like that. So I hope you understand my explanation. So again, if you have questions and queries, concerns, just comment it down below. I will try my best to reply your inquiries. So here let's have the peek function. So same with the stock, so return so in queue, when you peek, so we will return the front element of our queue. and in full. So we will use the rear variable if it is equal to our max size. So if it is equal to our max size, that means that our queue is full. So if we only set our array to 5 elements, so if our rear is equal to 5, then that means that our queue is already full and is empty. So we will use front. So if front is less than 0, so we will initialize our front into -1. So that's why if it is less than 0, so that means that our stack is empty because we haven't incremented our front. And also, if front is greater than the rear, that means also that our queue is empty. So these two operations here, this is used to check if our queue is empty. So front, if front is less than 0, that means that we still haven't added an element on our queue. And if front is greater than the rear, that means that we added an element on our queue, but we dequeued all of them. So that still means that our queue is empty. So if either of these two operations will be true, then that means that our queue is empty. Else, then return false. The queue is not empty. So that's it for today's video. I hope you learned something from me, and if you like my content, so don't forget to like, comment, share, and subscribe. So thanks for watching and have a good day.